Our next speaker is another one of our own. Brigadier General David J. Francis is the Commanding General today of the Combat Readiness Center and the Director of Army Aviation Safety. And Dave has just been announced to be the next Director of Army Aviation G357. I know he's dying to get into the Pentagon and the building and get away from that big luxury office that he has down at Fort Rucker. But anyway, Dave, please.
Thanks, sir. Well, good morning, everybody. I do want to say thanks to General Munt for allowing the Combat Readiness Center to get back on the docket here at Quad A. I think it's an important venue, and I believe that the discussions that we're having here, whether we're talking about training or modernization, all are about getting our soldiers ready to deploy in the most dangerous places on earth and to do it as safely as possible. So I got two good pieces of good news for you today. This is not a safety brief, although I will tell you, listening to some of the AAR comments from last night's activities, I think some of you need a weekend safety brief before you leave here today. So we'll ask the Sergeant Majors to post themselves around to get you squared away before you go on to your activities tonight. The second is I'm not going to take 30 minutes to do this. What I would like to do is just share with you from the Combat Readiness Center perspective kind of what we're seeing out in the force today and kind of what some of those implications are as we move forward, looking at things like future vertical lift and the future of training and how Army aviation operates as a force. And to do that, I want to just set the context for you just a little bit. If we can go to the first slide, please. So this is Army aviation since we become a branch in 1983. These are manned Class A mishaps. The blue represents the number of mishaps. The red represents the mishap rates per 100,000 hours. And what you see is that over time, if you take a look at the top left corner and you draw that straight line down to where we are today, we have done an amazing job operating very technical machines in very difficult conditions throughout our history to drive down our Class A mishap rates to the lowest that we've had in history. In fact, the last 3 years, our Class A mishap rates are lower than they have been throughout our history as a branch, with the exception of the year 2000, where we only had 6. But we're well on our way to that. But as you can see on the slide, where you see the circles there, we've had some spikes in those Class A mishaps. And each one of those is associated with a major combat deployment. So when we went to Desert Shield, Desert Storm, we went into a new environment, a large aviation force that is now flying low and fast. You know, we're flying at 50 feet, 120 knots. We started running aircraft into sand dunes, rolling aircraft over into FARPs, and so forth. And we learned from that, but we did suffer a significant increase in our Class A mishaps. And any of you who have had the unfortunate experience of experiencing one of those Class A's in your units knows the impact that has on readiness, not just from the material standpoint, but more importantly, the human impact it has on your organization, on your mission, on everybody in your unit that's associated with that Class A mishap. So it is a significant problem for readiness when we do have a Class A mishap. Then we go to Bosnia, and we go to Kosovo, where we're now in a mountainous environment, European weather, heavy Apaches. We suffer another significant spike in Class A mishaps. In fact, that's where General Cody went over with Task Force Hawk and came up with recommendations that we now see translated into AR 95-1. Then we continue on to OEF and OIF, and most of you have experienced that and lived that and understand what we went to. H4D2, high, hot, heavy, hostile, dark, and dusty. Right, all of those conditions that cause us to have, again, a significant spike in Class A mishaps. When we go to OIF, and again, we start with a surface air missile threat that drives us low and fast in a featureless desert and causes us to have those challenges. Now, if you take a look at where we were back here in 01 to 03 and where we got to today, you can see while that's a jagged line, we have made significant and consistent progress towards getting that accident rate pushed down. Now, what were some of those things that occurred? Well, we figured out that we probably ought to be sending units out to Fort Carson to do high altitude training. So we made that part of the standard process before operating in that environment. We enhanced our aircrew coordination training to facilitate better aircrew coordination. As you know, many of our accidents are caused by human error. Okay, we enhanced night vision goggle training. We modernized our aircraft. We put ASE on our aircraft that allowed us to come up in altitude, giving us increased altitude and decision-making space when things did not go exactly right. So a lot of those factors and many more combined help us to drive that accident rate down to where we are today. Now, I will tell you that, and I'm sure you've seen it on the news, the recent spate of military accidents across the services has caused a lot of attention to be focused on aviation mishap rates, on flying hours, on maintenance procedures, etc. We as the Army and Army Aviation are doing very well, but I say that with a note of caution. We cannot rest on our laurels, because just beneath the surface, and everybody in this room understands this, the difference between a Class A and something else is minuscule. It's seconds, it's inches, it's feet, it's position in an aircraft, it's where you are in relation to terrain. There are so many variables that could cause that number to go in a different direction very, very quickly, and we are all aware of that. And so what I'd like to just share this morning for just a couple of minutes from my current seat is some things I think we ought to probably take a look at as we continue to prepare for whatever is next. Because we're at that point in history. Now we're doing this. This isn't minute. This isn't an accident. We're still deploying forces. We're still rotating forces to Korea, to Europe, to Afghanistan, to Iraq, and other places around the world. So we're certainly not a less busy force. As General Gaylor said yesterday, aviation's in the neighborhood of 84% committed on any given day right now. Okay, doing all of that and maintaining the low accident rates is without question due to the leadership in this room and across the aviation branch. But again, we can't rest on our laurels, because that could change in a heartbeat if we allow ourselves to take a break. So the reason I put this slide up here is really to pose the question: what's next? What's that next major combat deployment? And are we doing everything that we possibly can to avoid that next spike in Class A accidents? You've heard it mentioned that throughout this week that our overmatch gap has narrowed a little bit, okay? That might drive us to change our flight profile and push us lower in our flight profile. Again, that pushes us down into an arena where we have less time to make decisions to correct problems, whether they are caused by the enemy or some other mechanical malfunction. And so I just have a couple of thoughts this morning on some things that we can do to help us to prepare for that. So if we go to the next slide, really this is about how do we expand that margin of safety. You know, General Conville uses the analogy that, hey, you can take a NASCAR driver and he can drive close to the curb at 100 miles an hour for a sustained period of time. He's got the training, he's always turning left, and he's got some consistent variables. But when we, as Army aviators, go into a new theater and we are putting our folks closer to the curb because we're closer to the ground with a whole bunch of other variables than that NASCAR driver has, then we have to do some things, okay? First and foremost, and General Gaylor mentioned this yesterday, there is no substitute for training. Training is the number one thing that we can do to reduce mishaps. The maximum amount of correct repetitions of a particular task are what's going to help us to keep that mishap rate down to where it is today. And that's something that we have to consider and we have to continue doing. Now, as we evaluate the threat, as we prepare to go to different contingencies out there, particularly those where the threat does drive us lower, I think we have to get back to some fundamentals that we may have gotten away from. Flying up at 1,000 feet and higher has allowed us to relax on a few things. And I think we have to get back to using our simulation to train emergency procedures. So there are probably a set of 5 or 6 emergency procedures that we ought to be training hard in the simulator so that it is absolute muscle memory, because when you are closer to the ground, you have less decision-making time and maneuver space to fix a problem. Again, regardless of the cause, whether that's enemy caused or a mechanical malfunction or whatever the case may be. And quite frankly, we're seeing that we have some work to do in that area. And the other is combat maneuvering flight, making sure that we are able to operate our aircraft to the limits of its performance adequately at lower altitudes. And that has caused us some challenges here recently. So training without a doubt is the number one thing that we can do. Now, as we look forward to building new aircraft, as we modernize the legacy fleet, I think there's some things that industry can do to help us with that. Okay? We got to reduce that complexity inside the cockpit so that our aviators can focus on the complexity outside the cockpit. And I know that we have a whole lot of initiatives that are designed to help us do exactly that. One of those, from my particular seat now, would be a playback capability. So right now, if we have a mishap, we dutifully go and we grab a flight data recorder, and we got to take it all the way back to our lab at Fort Rucker to process that data. How powerful would it be if we had, much like we have in our simulation right now, the ability to walk out of the cockpit, go into an AAR room, and replay that flight, okay? And I'm not just talking from an accident perspective. To me, that would be an invaluable training tool that IPs could use, that PCs could use out there as they're training the fleet. I think that would be a very powerful thing and something that would enhance our training and our ability and to be able to look at near misses. Right now, we have an initiative at the Combat Readiness Center where we have collected a bunch of near misses based on flight data recorders and input from units, where nobody got killed, but it was those inches or seconds that made the difference between a Class A and something else. So I believe that a lot of you have seen that brief, and we're going out to brief every combat aviation brigade in the Army right now. We've got most of them scheduled, and we're working on scheduling the rest of the Guard and Reserve as we speak. But that's turning out to be very, very powerful and really enhances my belief that if we could do that on a more normal basis, so I don't have to take a flight data recorder out, bring an aircraft down, send it back to Rucker for processing so that I can get the result. If we had that capability today in our aircraft to be able to do that, it would significantly enhance training and allow us to examine those things that lead us to having mishaps, whether they're cultural issues in a unit, training issues in a unit, individual or standards-based issues that we can get after. Okay? So training is important, and I think that's a capability that we ought to look at as we continue on. We looked at, as we went around some of the vendors yesterday, we were talking about DVE and some other things. And I will tell you that while 80% of our mishaps are generally caused by human error, that's a number that really hasn't changed throughout history. Despite the numbers going up and down, about 80% continue to be human error. So reducing that complexity is important. But spatial disorientation is another issue that has caused a significant number of mishaps. Even with our low numbers today, DVE continues to be an issue that leads to spatial disorientation. And that's an area that I think we have to continue to work on and continue to monitor. And as we think forward into the future, we can't be just thinking about landing in the dust, but all the other things that we do that potentially lead to spatial disorientation. Flying over water, flying over a featureless desert. As we get lower, that becomes even more critical because the time from the onset of spatial disorientation to a mishap is seconds. Especially the lower you go, it's pretty logical that the less time you have to identify and correct those issues. And spatial disorientation is a very, very powerful thing. When your brain isn't working right, because your visual cues aren't quite right, then we have a problem out there. That's something that we have to continue to get after from a safety standpoint. And it enhances our operational capability as well. And the last thing I want to just talk about very quickly is maintenance. While 80% of our mishaps are generally due to human error, it's not all in the cockpit. We have very complex machines that have critical flight components that require a significant amount of training and oversight and quality control to make sure that we get right. And we have found in several instances where if that's not done exactly right, it can lead to something that's more catastrophic. And we have to take a look at the maintainability of our aircraft the training for our maintainers and ensuring that we keep those folks up to speed. And in the future aircraft, we have to build them with that in mind. Okay, it can't just be a very, very complex machine that can do great things, but it has to be sustainable and it has to be maintainable to a very low level in less than ideal conditions. And if we can't get there from here, then we will continue to have some of the safety struggles that we've had in the past. So those are some of my thoughts here today. And certainly a lot of you in the room have developed the risk approval process that we have today. It works when we do it properly. And that's something that we also have to sustain and make sure that the next generation of Army aviators understands how we do that process and the critical importance of the mission briefing officer. So I think all of those things combined, and as we move forward with FVL and continuing to modernize the legacy fleet, if we can keep those things in mind and work towards those solutions, I think we'll be far better off in the future. And the last thing I'll say this morning is, as the Army safety guy, I'm not telling you to wrap yourself in bubble wrap. We are in a dangerous business. It's inherently dangerous. And what we cannot do is be risk averse. That's actually more dangerous than going out and doing that aggressive training that we need to do. We need to do that sequentially. We need to do it properly to get the max amount of repetitions, correct repetitions. But we do not want to be risk averse. That's probably the worst thing that we could do. And we might even bang up a few things in that process, but we will be better off when the chips are down, and we're going to send our young aviators into harm's way yet again to be able to handle that fight in all the different environments that we send them into. So we got to continue to train hard and in those most difficult conditions at those lower altitudes and do it right, and we'll be better off. Thank you for your attention, and appreciate it. Thank you.